Can you explain, the BEA has this jargon, you said use table, and they have some other types of tables. For those tables that they have that you've shown us in some Greek letters, can you show us the mapping? You know, what's a use table, what's a requirements table, or whatever it is?
Sure.
So these guys are going to look and they're going to have to make the choice which.
Right, which table to look at. Yes, for sure. So when you pull up the use table from the BEA, what you'll see, as I mentioned, is the values, how much each industry spent on intermediate inputs from every other industry. You will also see in the input-output table the sales of that industry. And so I mentioned before, here I've written costs, but because of our profit maximization problem, I could have written sales for the industry. What you would do for each industry is just divide the spending on each of its intermediate inputs by the sales in that industry, which you also see in the data, and that would give you the whole input-output matrix fee. There's a couple of complications there that in practice most macroeconomists even don't deal with. So next to the use table, you'll see something called a make table. And the reason for that is that the BEA defines tables as industries using commodities. So they'll have exactly the same name, but they'll construe, for example, one of these chairs as a commodity output of the chair manufacturing industry. What the make table tells you is whether there's any other industries that produce that same thing. So there might be another industry that also produces some chairs. Maybe chairs isn't the best example of this, but for example, hotels produce restaurant output because often they have room service and things like that. And so what you'll see in the make tables is, oh, there's some commodities, but it's actually produced by multiple industries. And so if you want to get into the weeds of that and how to create an industry by industry use table, I would direct you to that documentation. I think it would take a while to discuss here. But another thing you could look at, if you don't want to do the calculation, is the BEA also has something called a total requirements table. And the total requirements table is actually just this Leontief inverse computed for you. So if you pull up that table, you'll get exactly this matrix. And so you can look at precisely what is the total amount of input from every sector that's needed to create $1 of output in the sector in question. And so I guess now going back to Casey's questions about grocery stores, in principle, I think the way that retail shows up in the input-output tables is a little bit tricky, but in principle, you could look up grocery stores in the input-output tables in the total requirements table in particular and see how much farm goods actually went into $1 unit of their price index, what it is exactly that they sell. How important are farm goods?
That's what I did, whether it was allowed or not.
Okay.
I did it and I showed it.
Oh, great. Okay. Well, so long as it exists, I think it's the right thing, but not all retail sectors are covered. So one small point is that in the input-output tables, often things end at like the last layer of production. So like there's the carton of milk that emerges from the factory, and then that carton of milk may first go to a wholesaler and then a retailer, and you may see that in a separate table called the PCE bridge, if that's something that you're particularly interested in. But the input-output tables usually get you at least to the last rung, and then sometimes are doing something good about the wholesale retail stage. Yes, another question.
I'm curious about the timing when you use this model to take it to empirics. So suppose there's a sector that both depends directly on oil, like spot price, but also indirectly through a lot of intermediate goods, which probably takes some time, like there's a lag. So when there's a change in spot price and we want to like empirically estimate how that affects a certain sector, do you somehow account for those timing mismatch, or you may even have to use like the shares from different times if you believe there's like a T3 leg or something because of the intermediaries that it goes through, do some account for that, or is it too complicated?
Yeah, so, well, this was the question underlying my dissertation. So my dissertation actually deals seriously with the timing components, and shows that, if there are delays, the network really magnifies them. So like if there's a delay at each stage, there's going to be a much longer delay if you need to go multiple stages. And this generates a lot more persistence, for example, of a price shock, like an oil price shock, through to prices throughout the economy than you might otherwise expect. So this framework doesn't tell you precisely how to do that. I think my paper gives you one way of doing that. There's other ways to do that, though, from the framework of what Casey proposed, for example. So if you didn't have constant returns to scale, or you wanted to add, let's say, a capital input, you could say capital adjusts more in the long run than it does in the short run, and that's going to give you different price responses that are going to have implications for how price shocks propagate through the system. So there's many different ways of thinking about the timing, all of which are bells and whistles on this kind of frictionless setup, let's call it. Okay.